Good morning. I'm Julianne Ponder with SCD Probiotics. I can assure you this is my final presentation for those of you tired of hearing my voice. For this final presentation, I'm going to talk about pathogen control in water bodies. I'm going to talk about a broader term of pathogen control, a little bit about how SCD probiotics can control pathogens. We've heard many presentations throughout this conference about different applications where SCD probiotics can help with pathogens, human health, different environments, disease suppression, agricultural applications, and today I'm going to talk about a little bit of recreational water bodies, something we're working on a lot in the United States. So first I'm going to do an introduction of the probiotics and a little bit about how they outcompete and how we can control different pathogens in our environment. Then I'm going to do a case study review of a project we did in Los Angeles called Reseda Lake. So how can probiotic technologies work for beaches, lakes, and other water bodies? In the U.S., I don't know that much about here in Europe and other parts of the world, if this is as much of a growing problem. I anticipate that it is. We are experiencing a lot of problems with pathogen introduction into all different areas, including recreational water bodies like lakes, beaches, parks, all kinds of places like this. There are many different potential sources. A lot of times it's just overpopulation. There's a lot of people there visiting. They bring with them lots of food sources, lots of pathogens. Just in their natural environments while they're visiting, they're introducing a lot of nutrients and or pathogens into that environment. There's also some information or some theories on land-applied sludge. While we're trying to be more sustainable and use the sludge produced in wastewater systems around the world, we have to make sure that it is low in pathogen counts or free of pathogens. We're applying it to land, then when we have rain events, it's flowing into all these water body systems and affecting us greatly. There are many other different types of sources of pathogens. Today I'm focusing on mainly fecal coliforms, specifically E. coli. That's what we're dealing with in one of the regulatory parameters in the United States. Here's a statistic here that closed beaches due to pathogens cause a loss of swimming opportunities valued at over $2 billion annually in the United States alone. This is a loss from swimming-related illnesses up to $28 billion. This is reported by Environomics in 1995. So you can probably imagine it's probably even more substantial today. So what are the antimicrobial effects of SCD probiotics and how do they work? As we've talked about plenty today, Rupert touched on it, the consortia idea. The idea that each group in our consortia adding something creates better than all of them individually. So through this, some of the probiotics in our microorganisms, through their metabolic process, create metabolites that have an inhibition zone or inhibit the growth of pathogens near them. It's just a defense mechanism. It's a way for them to take over and survive in different niches. They also have competitive exclusion properties, meaning they create their own microbial environment by interacting with each other. So they become all the insiders and the in crowd, if you will. So nobody else can get in. It's harder, and they take over that environment, the nutrients, and everything else. So when pathogens are introduced, they don't have as much of a chance of taking over that whole environment and causing the problems that we hear about. Now at SCD, we did an internal antimicrobial study. We focused on several types of pathogens. Specifically today, I'm going to talk about some of the ones that we're focusing on projects in the U.S. Like I said, the first is E. coli, Pseudomonas aeruginosa, Salmonella, and Staphylococcus aureus, all diseases affecting humans whenever they swim or enter or are subjected to these pathogens, have different illnesses and different negative side effects. So we did a study in-house, as I said. We took our probiotics and we plated them with a certain level of pathogens present and then recorded how quickly the populations of those pathogens decreased. Now, this was done on a lab scale, so as you can imagine, it's a little bit different whenever you apply it into real-world environments, but this is a great visual to how quickly and how healthy our probiotics are for outcompeting these pathogens. So you can see here, along this axis is the different pathogens tested. Along this axis, this line is the inoculation level, meaning how many we actually inoculated within that Petri dish. And then along here is the different days, how long it took for us to reduce them significantly. You can see for Staphylococcus aureus, E. coli, Pseudomonas aeruginosa, the inoculation levels significantly high, and usually around day 0, before day 1 was over, we reduced them significantly. The only one really that made it past day 1 is Candida albicans. This is a great visual way to show how quickly we can solve some of these problems. It is a long-term effect, but it's something that we can see results and start to show people. Now, the specific project I'm going to talk about, the case study review, is Reseda Lake. This is a park in Los Angeles, California. It is a small recreational lake. It's not a swimming lake. It's just there to walk around, have picnics, feed the ducks, that kind of stuff. We did this project between 2008 and 2009. Our partner with this was Organic Environmental Technology, one of our licensees in California. Now, the problems they were facing here is that their pathogen levels were over regulatory limits. Even without being a swimming beach, they were still above thresholds. There were many theories as to why they were so high. The most popular was waterfowl. They had many ducks and other waterfowl that would come to this lake. And high introduction of nutrients, because everyone would come visit the lake and feed the ducks and throw in a whole loaf of bread with their kids to have fun. So the nutrient load in the lake was a little bit off. So we took baseline measurements in 2008 and then started applying the probiotics in 2009 and took samples throughout. So to identify our objective, the reported limits were for E. coli, that they were outside of or above the regulatory limits. So we analyzed E. coli, Enterococcus, and total coliforms. All 3 of these parameters, they were too high in. Products we used to do this, the first was liquid probiotics. We used SCD BioClean, here on the left, the liquid, and SCD Clean Sinkers, solid form of bokashi that you drop into the water, a time-release tablet, basically, of probiotics. Here's an overview of our results. You can see basically the baseline data, or before. For E. coli, it was over 4,000. Enterococcus, also over 4,000. Total coliforms was at 15,000 MPN per 100 milliliter. After SCD probiotics, you can see it's a pretty drastic difference. For E. coli, we got down to 8, with the city standard or regulatory limit being at 576. Enterococcus, we got down to 3, the city standard being 104. For total coliforms, we got down to 30. City standard is 1,000. So you can see that significantly by all the city standards, we were reduced and got them within limits. So in summary of this case study, we had significant reductions of pathogens, which was our objective. E. coli was reduced by 99%. Enterococcus was reduced by 99.9%, almost eliminated. And total coliforms were reduced by 99.3%. We reduced all the pathogens to below regulatory limits. A point I want to make here is in discussions with different governmental agencies and even just potential clients talking about pathogens, it's never really a goal or intent to completely eliminate pathogens. They serve some role in our world. They do something. Using the probiotics, so many people are so used to thinking of chemicals that you eradicate them, you get rid of every trace of pathogens. We're just going to keep them in check. We're going to play a game of population dynamics and make sure that the bulk of the population are beneficial. It's something that I personally have to explain over and over and over again, that yes, E. coli can have very negative effects, but that doesn't mean we have to completely eliminate it from every system and every environment. It does have its place. So while we have very significant results here, the idea is to take over the ecology of that system with beneficial microorganisms where it's already been imbalanced by pathogens. So thank you once again. If you guys have any comments or questions, please follow us on Twitter.